Welcome back. Today we are doing lesson 11.9, which is all about z-scores and standard normal distributions. So the standard normal distributions should look somewhat familiar. It's the normal distribution that we've looked at before with that empirical rule from the last lesson, but now the mean is going to be 0 and the standard deviation is going to be 1. That's what makes it standard normal distribution. So that word standard always means in this case that the mean is 0 and the standard deviation is 1. So from that, we're going to build what's called a z-score. So a z-score is the number of standard deviations that a data value is above or below the mean. So it's a measure of how many standard deviations away from the mean a certain data value is. So you can see over there that the formula for a z-score is to take the data value, x, minus the mean, and divide by the standard deviation. So that's how we calculate a z-score once we kind of know all the information. So let's do a little practice with the formula there. So in example A here, it says a market researcher is analyzing the results of a customer survey that ranks a product from 1 to 10. If the mean is 8.5 and the standard deviation is 1.2, we're going to find the z-score for the data value of 9.1. So to find our z-score, we use that formula, which is to take the data value and subtract the mean, and then divide it by the standard deviation. So we just have to pull out the important pieces of information there. In this case, that puts our z-score at 0.5. So that means that it's a half of a standard deviation away from the mean. Okay, so for our next example, the average temperature of a city is 84.6 degrees with a standard deviation of 3.8. If the z-score is 2.5, what's the temperature today? So we have to figure out what are they asking about. So in this case, they are asking about the temperature today, which is our data point. So we know the z-score is 2.5. So we need to find the data point that is going to give us that z-score. So we're going to plug everything else into our z-score formula, and we're going to solve it. So we're going to multiply by 3.8 on both sides and get 9.5. And then to finish isolating x there, we'd add 84.6 to both sides. And that tells us that temperature for that day is going to be 94.1 degrees. So it works both ways. We can figure out certain data points, we can figure out mean, standard deviation, we can find all the different pieces that we need to find. All right, let's look at this next one. So this time it says the cost of sandals has an average or mean of $18.30. If the z-score for a $23.70 pair of sandals is 1.8, what's the standard deviations? So they're telling us that the z-score is 1.8. So we know that it equals 1.8. And we know that the sandals cost $23.70 when the average is $18.30. We're trying to figure out what standard deviation would produce that z-score. All right, so in this case, we can simplify that numerator, subtracting those, and I get 5.4 or $5.40 divided by the standard deviation. When we isolate the standard deviation, we end up doing 5.4 divided by 1.8, and we get a z-score of 3. Or sorry, a standard deviation of 3. So the standard deviation would be 3 in order for 2370 to be 1.8 standard deviations away from that mean. All right, let's look at example D here. So a set of exam scores has a z-score of negative 0.4. So I'm going to write that down with a standard deviation of 2. If your score was an 81, what is the mean for that test? So we're going to multiply both sides by 2. Get negative 0.8 equals 81 minus the mean. Subtract the 81 and then divide out the negative. We get the mean score is about 81.8%. So your score of 81 was about 0.4 standard deviations below the mean. Okay, so the last thing we're going to do here with these z-scores is we're going to kind of use them to start comparing some information. So in these normal distributions, we're going to compare kind of what's going on. So it says you want to compare your math and your science test scores. You want to figure out, are you doing better in one class than the other? So based on the data in the tables, which scores is better? So we can standardize them with the z-scores. We can compared to their own means, which one's better or worse, so that we're comparing them to things that are similar. So for math, we have a score of 88 with a mean of 75. So you're above the mean. And the standard deviation was 8. When we calculate that z-score, it comes out to about 1.625. So in that class, your score is about 1.625 standard deviations above the mean. In science, you scored an 84, which is obviously lower than the math score, but the average was a 72, which is also lower. The standard deviation was also lower at 6 instead of 8. So we want to compare that. So z-score wise, when we subtract 72 from 84 and divide by 6, we get a z-score of 2. So let's talk about how we might compare those. So in math, you're 1.625 standard deviations above the mean. In science, you're 2 standard deviations above the mean. So what that means is that your science score is better. Even though it was a lower score, it's better because it's better relative to what else is going on in the class. Your science score was more standard deviations away from the mean, meaning it was even better than the math score. All right, let's look at one more example of that. So same idea here. We're going to compare 2 things. So we're going to compare 2 house prices in different towns to figure out which one am I getting a better deal on. So which house is a better price compared to the other houses in that particular town? So for town A, you are looking at a house that's $450,000. And the average house price is only $375,000. So when we divide that by the standard deviation of $50,000, we get a z-score of 1.5. So the house you're looking at is 1.5 standard deviations above the average house in that town. In town B, we are only looking at a $380,000 house. So much less expensive overall, but houses in that town only average $250,000. So when we divide that by our standard deviation for that particular town, we get a z-score of 3.25. So even though the house is cheaper, it's much further away from the average for that town than in town A. So if we're trying to figure out which one's the kind of the best bang for your buck, town A, the house in town A, is a better price. Because relative to the other houses in that town, it's closer to the average. So it's not as drastically far away from the price that you would expect. Even though $380,000 is a less expensive house, compared to other houses in that town, you're paying a lot more. So that's some information about z-scores and the standard normal distribution. We'll see you next time.